Okay, now in this section 6-2, we're looking at laws of exponents part 2. And in this section, we're going to utilize what is known as the quotient rule. Okay, so last time we looked at what happens when you multiply two expressions with exponents by each other. But now we're going to look at, see what happens when you divide them out. Well, if you have x to the a power divided by x to the b power, the bases are alike. What do we do with the exponents to get the answer? We will take those exponents after we write out our common base and then subtract them. Okay? So x to the a divided by x to the b equals x to the a minus b. You will subtract the exponents. I'll show you why here in just a moment. Okay, so let's look at number 1. So it says y to the 5th divided by y to the 3rd. Okay, so here's really what's happening. Y to the 5th, remember, means y times itself 5 times. 1, 2, 3, 4, and 5. All right? And y to the 3rd means y times itself 3 times. 1, 2, and 3. And so really, if I were to divide this out, then 3 of these would cancel out with each other. The 3 on the bottom would cancel out with 3 on the top, become 1, right? And then 1 times y is just y times itself twice, which is y to the 2nd power. And we can utilize the quotient rule instead of having to write this out every single time to say, okay, y to the 5th divided by y to the 3rd. What do? Subtract the exponents. 5 minus 3 is 2, and we can just immediately write y to the 2nd power, and then that will save us some time. All right, so a few more examples to look at. K to the 12th divided by k squared. 12 minus 2 is 10. The answer is k to the 10th. M to the 3rd divided by m to the 3rd. Now, 3 minus 3 is 0, right? So that's really technically m to the 0 power. And don't forget, anything to the 0 power is equal to 1. Okay, so the answer here is 1. And that makes sense because if we wrote them out, m times m times m divided by m times m times m, the m's would all cancel out, all of them, and leave you with just 1 over 1, which is 1. Or if you just look at it from the beginning, m to the 3rd divided by m to the 3rd, okay, we know anything divided by itself equals to 1. So any way you look at it, you get the answer of 1. All right, so on this one, we've got 2 letters to contend with here. No matter, we'll still use our quotient rule. So a to the 7th over a to the 3rd, I need 7 minus 3, which is a to the 4th. And 6 minus 5, which would be b to the 1st power. So since that's 1st power, I just have to write b. I don't even have to write the 1. All right, so the next one we're looking at, p. So I've got p to the 7th over p to the 4th. Well, what's 7 minus 4? That's 3. And I've got q next. 16 minus 12 leaves me with 4. So there's the answer there. The next one involves 3 different variables. That's fine. Start with the x's first. 10 minus 5 is 5. Y. 9 minus 9 is 0. So y to the 0 is just 1. So 1 times x to the 5th is x to the 5th. I don't even need to write the y at all because it becomes 1. And z squared over z, one of those will cancel and make z to the 1st power, which again doesn't have to be written because if I write z, it means automatically 1st power. All right, so there you go. Let's see. The next set of examples now deals with coefficients. So we're going to have numbers in front of our letters this time. Kind of like what we had in the last section when we were multiplying. Now we're just going to be dividing with the numbers. Same type of rule applies. You're going to divide out these numbers first and then deal with the letters second. So here I'm going to deal with the 6 divided by 2 first, which is going to give me 3. And then I've got x to the 4th over x to the 3rd, which will be x to the 1st power. I just write x, and then I have my answer of 3x. All right. So again, deal with the letters first. In this one, we're going to have 4 divided by 8, which can reduce now. So I'm going to have a fraction actually on this one. And so 4 over 8 reduces to 1/2. So the 1's on the top, the 2's on the bottom. And remember, that's going to be 1 multiplied by whatever this n is going to be left with on the top. 5 minus 1 is 4, so that's 1 times n to the fourth, which is just n to the fourth. So n to the fourth over 2 is going to end up being your answer. If you end up with a number on the bottom of the fraction, then you're just going to have a fraction. If there was a number left here that was not 1, we would just write it up here in front of our n. Like, for example, if this was a 6 instead of an 8, that would reduce to 3/4, so I would have 3n to the fourth over 4. So if there's a 1 here, that's the only time you don't have to write it. Okay, any other number would have to be written outside of here, so keep that in mind. All right, so next one we're looking at, 14 divided by 7. That's going to leave me with 2. And so from here now, r squared divided by r leaves me with r to the first power, which is just r. And 2 minus 1 again is s. So I have 2rs as my answer for number 9. Then once we get to number 10, we'll have 36 over 48. Now, what I would suggest on this one is use your calculator to reduce the fraction. Put 36 divided by 48 and press enter, and you would see that that reduces to 3/4. So that's kind of what I was saying earlier. We now have a fraction where we're going to have 3 on the top and we're going to have a 4 on the bottom. Now, let's see what our letters end up with. So 11 minus 5 is 6, so that will be g to the 6th on top. 7 minus 3 is 4, and then so that's h to the 4th on top. So there's your answer. 3g to the 6th, h to the 4th, divided by 4. All right, let's take a look at number 11 here now. And in number 11, once again, I've got to take into consideration the coefficients. First, I have a negative divided by a positive. All right, so what that tells me is my answer is going to be negative. And 21 divided by 7 is 3. All right, and then 5 minus 1 is c to the 4th. And 8 minus 6 is d squared. So remember, you're subtracting the exponents of the letters with the same base. So subtract 5 minus 1 to get 4th power, 8 minus 6 to get to the 2nd power for the d's. All right. Let's take a look now at the next one that we're going to be looking at. So here I've got negative divided by negative, which is a positive. So I know my answer is going to be positive. Then I've got 25 divided by 5, which is 5. So I'm going to write my 5 first, write the coefficient first. Then from here, I'll take into consideration the letters. So I'm going to have x, 7 minus 3 is 4. I'm going to have y, 10 minus 7 is 3. And I'm going to have z, 4 minus 1 is 3. And then so my answer is 5, x to the 4th, y to the 3rd, z to the 3rd. Okay, now, one situation that we may encounter that we have not taken into consideration with the examples that we've used here would be, what happens if the coefficient on the bottom of the fraction, or excuse me, the exponent on the bottom of the fraction is larger than the exponent on the top? In other words, you get a negative number when you subtract instead of a positive number. That is this example that I'm going to show you on the back of this sheet. So suppose, for example, that we ended up with this. We ended up with 6x, or started out, not ended up, started out with 6x to the 5th, y to the 4th, z to the 2nd, and all of this is over 4x squared, y to the 6th, z to the 8th. All right? So now, in this example, when we start dividing it out, 6 over 4, that reduces to 3 over 2. So I'll have a 3 on top and a 2 on the bottom. Okay, so I'm reducing that fraction first. Now, x to the 5th divided by x squared, 5 minus 2 is 3. My x ends up on top. It's x to the 3rd. All right, so no problems yet. However, once we get to y, take a look at what happens. Okay, I've got y to the 4th over y to the 6th. Well, 4 minus 6 is negative 2. All right, so what that means is, if you end up with a negative number, that means instead of the y ending up on top, it's going to end up on the bottom of the fraction. So I have to write the y on the bottom, not the top. And 4 minus 6 is negative 2, so that becomes y to the 2nd power. All right, so let me give you another example of why that's the case. Remember, y to the 4th means y times itself 4 times. Right? And y to the 6th means y times itself 6 times. Well, when I start canceling these out, 4 from the top will cancel with 4 from the bottom, but what are we left with? We're left with 2 y's multiplied together on the bottom, and y times y is y squared, so that y squared is left on the bottom of the fraction, because once they cancel out, you're left with 2 on the bottom. So anytime you subtract and get a negative number, that means that you're going to end up with that variable in the bottom of the fraction with this exponent. Okay, so with that number. So since 4 minus 6 is negative 2, the negative tells you it's going to be on the bottom of the fraction, and then you just keep the exponent of 2. All right, so keeping that in mind, we can now finish the z portion of it. So I know it's going to be 2 minus 8 is negative 6. So since it's negative, that means my z is going to end up on the bottom of the fraction with 6. So here's another way you can think about it. If I have 2 z's on top and 8 on the bottom, once they cancel, I'm going to be left with 6 on the bottom of the fraction. So that's another way to think about it as well. So just remember, when you end up with that negative exponent, that means that that variable is going to end up on the bottom of the fraction with that exponent changed back to positive. 2 minus 8 is negative 6, and then so that means it's going to end up on the bottom of the fraction as a positive 6. All right, so just keep in mind that scenario where you subtract and get a negative number for your exponent. Or another way you can think about it, like I said again, if I've got 4 y's on the top and 6 on the bottom, when they cancel, I'm still going to have 2 y's on the bottom, y squared on the bottom of the fraction. So that's the way that you can consider that. Okay, so at this point, you are now ready to do your next quiz, which is quiz 6-2. So you can find that in Canvas. Remember, before you leave at the end of the period, make sure that you have both of the warm-ups and both of the quizzes completed in your Canvas course.